to Chemistry e-Learning by Fatima Convent High School. Mrs. Deepali, your teacher and creator of this content, will guide you throughout your chemistry journey.
Hello everyone, welcome back to Class 9, Part 3, Chapter 1, Matter in Our Surrounding lecture series. Now, in the previous lecture, we understood characteristics of particles. Today, we are going to see the activities to understand these characteristics in more detail. Particles of matter are very small. This is the first characteristic we understood. Now let us prove it with the help of an activity. Take 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. Potassium permanganate is crystalline, dark pink colored substance easily available. Its chemical formula is KMnO4. Now take out 10 ml of this solution and put it into another beaker and add 90 ml of clear water to it. You will observe that the dark pink color has changed a little. Take out another 10 ml of this solution from beaker 2 and put it into another beaker and add 90 ml of clear water to it. Keep diluting the solutions like this way until you prepare 5 to 8 batches in a similar manner. What do you observe? Yes, the color of potassium permanganate, which was dark pink in the first beaker, goes on becoming lighter till the end. But it persists. It does not become completely clear like the first beaker of plain water, which shows that even a small crystal of potassium permanganate can color a large volume of water. From this we can conclude that there must be millions of tiny particles in one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. You can perform this activity by replacing potassium permanganate with Dettol. You will observe at the end of the activity that the smell of Dettol persists till the last beaker even after repeated dilution. This shows that the particles of matter are very small. They are small beyond The next property we came across was particles of matter have space between them. Now we all are familiar with tea, coffee or lemonade. If you have tasted this and try to taste the sip of each drink, each time is similar. There is no difference in the first sip and the last sip of your drink. This shows that there is space between the particles of matter. But how? Now, when you add salt or sugar to the lemonade and lemon juice, the particles of sugar and lemon mix evenly in the particles of water. This is possible only when there is enough space between the particles of water to allow the particles of salt or sugar and lemon juice to mix with it. This space is called as intermolecular space. So you can define this intermolecular space as space between two molecules or atoms of any substance. This intermolecular space of atoms or molecules play a very important role in defining the properties of solid, liquid and gaseous state. Particles of matter are continuously moving. Let us see this property on the basis of gaseous state. We all are familiar with an incense stick. If you place an unlit incense stick in any corner of your class or a home, you will be able to smell it only when you go close by to it. But when you light the incense stick, even if you are outside the class or far away from the incense stick, you will be able to observe that the smell of the incense stick reaches your nose even at a greater distance. How did this reach your nose? Due to the movement of the particles. Now, let us see, does the particles of liquid state move? If you take a glass of water and add few drops of ink to it, you must have seen that the drop of ink moves down to the bottom of the glass. If you take a drop of honey, you will observe the similar thing, and you will observe that the ink or honey spreads into the water on its own. This process of mixing shows that the continuously moving particles of matter. Now, let us see with the solids. If you take the crystals of copper sulfate or potassium permanganate and you mix it with water, you will see them dissolving in water on its own without even stirring the solution. How did this happen? This happened with the process of diffusion and due to continuous motion of the particles of matter. The fourth property says particles of matter attract each other. Let us take an iron nail, a piece of chalk and a rubber band. Try to break them by hammering, cutting or stretching. What do you observe? If you try to hammer it, you will see that you will have to apply lots of force to it, or even it might not break. If you try to break the particles of chalk, then they will break, but not completely. Same way, if you stretch a rubber band, they will stretch to a certain extent. is holding these particles together and not allowing them to separate out easily. This force is intermolecular force of attraction. Intermolecular force of attraction can be defined as the force which mediates interaction between molecules, including force of attraction or repulsion, which acts between molecules and other types of neighboring particles. Example, atoms or ions. Now let us see the effect of temperature on kinetic energy of particles. Now what is kinetic energy? The energy which a body possesses by the virtue of its motion is called kinetic energy. We can also say that any substance in motion possesses kinetic energy. For example, all of you must have played the game of pinball. You take a ball and hit the pins, they will fall. How did the ball make the pins fall? Because the motion of the ball had energy in it, and this energy is called kinetic energy. This kinetic energy is even present in the particles. Why? Because the particles of matter are continuously moving, and due to that they possess kinetic energy. Now let us see how the temperature affects the kinetic energy of the particles. As the temperature increases, the kinetic energy of the particles will increase. Because of this, the motion of the particles also will increase, and this will cause the change in the state of matter, about which you will study in detail further in the chapter. So, as the temperature increases, kinetic energy of the particles increases. Now let us see effect of heat and temperature on diffusion. What is diffusion? Diffusion is the intermixing of particles of two different types of matter on their own. Did you all see this illustration in the previous slide? Yes. When we check the particles are continuously moving, we saw how potassium permanganate or copper sulfate or ink drop or a drop of honey or the incense stick smoke got mixed up easily with the other particles. This shows that the particles are continuously moving. Just as kinetic energy increases with increasing temperature, the rate of diffusion also increases with increasing temperature. Do you know the reason for this? Yes. The reason is, as the temperature increases, we understood that kinetic energy increases, and so the particles will be moving constantly, and the intermolecular space between the particles will increase. Now, as the space increases, the particles of the substance which we are trying to dilute or add to the solution will have enough space to spread faster. and so it will get mixed up faster into the solution. This shows that with increase in temperature, diffusion and kinetic energy of the particles increases. So, hope you all understood the properties of particles of matter clearly now. That's all for today. We shall start with the new part of the chapter, States of Matter, from the next video. Thanks for today.